Having explained the bond behavior of reinforced concrete, we can now explain the tests for determination of bond strength of reinforced concrete in detail. There are three known tests for determining the bond strength and bond slip of reinforced concrete. Pullout test, which is conducted on a cuboid or cylindrical specimen. It's most commonly used and predicts bond strength and tension. A push-out test is a bit complicated as it involves recording slip through strain gates. It's mostly conducted on cylindrical specimens. It records bond strength and slip in compression. Third one is the flexural or the beam bond test, which involves determining bond strength and flexure on beam sample. Most of the tests that are conducted are monotonic loads. A pull-out test is the basic test. A steel rod embedded in concrete and concrete sample being restrained is pulled in tension. An LVDT connected to the other end of the steel rod restrained over a box assembly records slip. The box assembly is of heavier material with more strength and is made up of steel rods. Another LVDT records secondary deformations in the box assembly. The steel rod is divided into unbounded and bounded lengths. The pull-out sample has a bounded and unbounded lengths. Now the lengths are varying. The minimum bounded length for cylindrical specimen is 40 to 50 mm, being 2.5 times the diameter of a bar. The unbounded length is 60 to 100 mm and the grip of steel bar is 50 mm to 350 mm. The cylindrical specimen dia is usually 100 to 150 mm and the height is 100 to 200 mm. For cube test, pull-out specimens are taken with a bounded length of 40 to 50 mm, the unbounded length is 60 to 100 mm and the grip length is 50 to 400 mm. The specimen, which is a cube, has a width and a height of around 100 mm to 200 mm. Mostly steel bars are used and which have a diameter of 10, 12 and 16 mm for doing this test. The steel bars used in testing for bond strength may have different rib shapes and they give different results for the bond and stress and slip. The basic one is the rounded shape, which is mostly prevalent. The other one is the rectangular shape of the ribs. The third one is the cross winding rib. The fourth one is the spiral winding rib, and the fifth one is a crescent rib. The unbounded length may be achieved by a plastic pipe sleeve of thickness 2 mm. This is put over the steel rod or the steel bar. Alternatively, a gap in the sample may be provided. And thirdly, a gap with the notch fixed or fitted is provided to avoid any bearing stresses. The failure patterns obtained are seen in the cube samples as splitting failures. The bond stress to slip patterns are recorded, as can be seen here. The load cell measures the bond stresses and the LVDTs measure the slip. Another test commonly used in determining the bond strength is the beam test. The steel portion is kept unbounded to determine relative slippage of the center of the sample to the end of the sample. The displacement meter is kept at an end to record slippage. Here the sample is under a cyclic load. However, a monotonic load can also be applied for this study. Finally, a push test is conducted on a cylindrical specimen. The same is meant to study the bond behavior under compression. The slip of the steel is recorded by a black colored strain gauge. These strain gauges record the slip, while as the load is determined through a load cell, and finally a load cell plot is determined.